Hello everyone. In this video, we will learn about branching combinations in UML activity diagrams. A branching combination must be defined carefully so that the activity can deliver the expected behavior. A wrong combination may lead to unexpected behavior. I am Tedu Digahayu, at the undergraduate program in Informatics, Universitas Islam Indonesia. How to design the behavior aspect of software. We have seen that there are 4 branching notations in UML activity diagrams, namely, decision, fork, merge, and join. With these 4 notations, we can define 4 branching combinations, along with their implications, as shown in the following table. The first combination is decision merge. This combination represents a selection, which will run without any problem. The second combination is decision join. This combination will result in deadlock during the activity execution. Then, the third combination is fork join. This combination represents parallel execution, which will run without any problem. Finally, the fourth combination is fork merge. This combination may result in a race condition during the activity execution. We will discuss these combinations one by one. The first combination is decision merge. This combination is shown in this example. It is an activity diagram of an ATM or money dispenser machine. The activity begins with the action of insert card and PIN, followed by the action of enter amount of money. After that, we have a decision. If there is enough money in the owner's account, the action of dispense money will be executed. But if there is not enough money, the action of reject transaction will be executed. These 2 actions are followed by a merge that leads to the last action, namely take out card. The action of take out card will be executed only once, that is, after the action of dispense money or reject transaction has completed. This can be ensured. The decision before those 2 actions makes only one action will be executed. The execution cannot be both. Thus, in the execution of this activity, the action of take out card will only be executed once. The second combination is decision join. This combination will result in deadlock during the activity execution. Consider this example, that is similar to the previous example. Except that, the merge notation is replaced with a join notation. We focus on the join notation. By using a join, the action of take out card can only be executed if the 2 source actions, namely dispense money and reject transaction, have completed. Is it possible for both source actions to be completed? Of course not. Because the previous branch uses a decision, only one of the actions of dispense money and reject transaction will be executed. It is impossible for both source actions to be executed. This makes the action of take out card wait forever, because only one of the source actions has completed. Thus, in the execution of this activity, there will be deadlock. The action of take out card will never be executed. The third combination is fork join. This combination is shown in this example. It is an activity diagram of a journal management. The activity begins with the action of receive paper. It is followed by a fork that has 2 target actions, namely, review 1 and review 2. This branching is then brought together with a join. This join leads to the action of decide result, followed by the action of send result. The actions of review 1 and review 2 will be executed because they were branched by a fork. The action of decide result will only be executed when the actions of review 1 and review 2 have completed. It should be understood that this combination implies parallel execution. However, the implementation does not always have to be done simultaneously. This will not cause any problem for the execution of subsequent actions. Thus, in the execution of this activity, the action of decide result, as well as the action of send result, will only be executed once. And the last combination is fork merge. This combination may result in a race condition during the activity execution. Consider this example, that is similar to the previous example. Except that, the join notation is replaced with a merge notation. We focus on the merge notation. As mentioned previously that, the actions of review 1 and review 2 will be executed because they were both branched using a fork. When the action of review 1 has completed, the action of decide result can be executed and then followed by the execution of the action of send result. If, at some time later, the action of review 2 has also completed, the action of decide result will be executed again. After that, the action of send result will also be executed again. So, like a race, the action that completes first can start executing the action of decide result. This may give an uncertain result. Thus, in the execution of this activity, a race condition occurs. The final result of the target action depends on the result of the source action that has complete the latter. We have 4 branching combinations that can be modeled in UML activity diagrams. It should be noted that a branching combination does not have to be a decision merge combination or a fork join combination. We may use other combinations, if indeed the logic is expected in the activity. Branching combinations must be used carefully to model the expected behavior of an activity. We have to consider the implications of the branching combination, especially those that might result in deadlock or race condition. This was an explanation of branching combination in the UML activity diagram. The combinations discussed in this video are decision merge, decision join, and fork merge. Thank you.